Hey, this is OXDF, and today we're going to look at a hash extension attack. Specifically, we're looking at a situation that came up in the Ouija box from HackTheBox. Um, and yeah, hash extension is a really cool technique. I've shown it, I think, three times before on my blog. But it has to do with attacking how hashes work, like MD5, SHA-1, SHA-256. And so in a scenario where someone has a secret that I don't know, and then some data that I do know, and they append the secret and then the data and hash it, and I know that hash. I can actually add stuff to the end of that string with a little bit of padding, and then calculate a new hash. Even if I don't know the secret, I can get the resulting hash, and so still have a valid hash. So this is an insecure way to do like signing and checking of keys with like a web application. That's what we have here. So I'm going to set up this. We'll walk through what the scenario is, and then I'll show how we attack it. We're also so there's a tool called hash extender we're going to use, but it requires you to know the length of the secret. So we're going to use a Python wrapper to show how we can just check every length until we find it. So let's go ahead and take a look at the scenario. I've got a couple of files here, app.js and init.sh. I'm going to actually go ahead and open up VS Code here so we can take a look here. And we'll start with this init.sh real quick. Basically, this has, frankly, a really bad shell script. That like wouldn't work because like there's no file here, it's broken. But I can pull a few things out of it, like this bot ID and this hash is what I'll need. I also need to note that like there's a key that I don't have access to, so I can't know what that is even with access to this thing. And so we'll use that. Let's come back here and look at this is the API that we're attacking, and you know I'm not going to go through all of this, but the interesting use case we'll look at here is this /users. Now it doesn't actually, no matter what happens, it just returns database unavailable, but it calls ensure auth first, and that's going to be our test for if our auth is working. And if we look at the ensure auth function here, it makes sure that there's an iHash header, an identification header, otherwise it complains. Then it's going to verify cookies on the identification header and the iHash header. And if it fails, it responds invalid token, and then it's going to check if the identification ends with admin true, in which case, if not, it says insufficient privileges. Otherwise, it continues and does what you want it to do. So up here, we can see, if we look here, ours does not, this hash is the secret plus bot1 : bot does not end in : admin true. And so that we have this hash, but we can't use it, right? Because we don't have admin true. Let's demo some of that. So we can start with, let's say like ouiga.hackthebox : 3000/users. And so we expect to get missing headers, since we get the iHeader hash is missing. Minus, so if we do iHash, oops, that's a header iHash, like that, and then we'll grab this right here is here. And we include that. We now get the identification header is missing. I'm going to add an echo to the end here because so I can get that back. Let's grab the identification header. Now, my first thought was like, oh, that's going to be bot. I'll show you that actually doesn't work. I'll show you why. That is identification like this. I get invalid token. Now I expected to get where are we? Insufficient privileges. The problem is that the token is being passed, let's see, verify cookies, is being passed to this D function. So it actually needs to be base64 decoded and then hex decoded. I don't know why anyone would ever design something that way, but that's what we need to do. So we can do echo -n bot1 into xxd minus r minus p minus r minus, oh, sorry, just into xxd minus p to give us, that'll give us the hex version. So that's like b, o, t, etc. And then we put that into base64. And now we have this. And so now when we go here, the identification is encoded. We get invalid token. By the way, that failed. Let's see. Bot1 into hex into base64. So we're going to base64. What am I missing here? Is it bot1 Is that right? Check this out. Oh, did I do bot? I did. Let's see, where are we here? It's bot. It's bot1 I think, like that. So let's try that again. You insufficient privileges. Sweet. So we've shown that we can now get in here all the way to, we've got a valid hash. The hash is good. The signature is good, but we can't get past here because we don't end in admin true. So we have the scenario, we want to extend our data, but we don't know the secret to append, and that's where we use this hash extension attack. So I'm going to show you, let's see, if I do op hash extender, now I'm going to have to give this a few things. We'll give it data, bot1 bot. We're going to pass in append. Like, what are we going to append to it? We're going to append admin true. That's what we need it to look like. The signature, the valid signature we have so far is this right here. The format is SHA-256. And the last thing we need to know is the secret length. And we don't know that, right? We have no idea what the secret length is. So for now, I'm just going to try 8, right? So if we try 8. And what it's going to give me is, okay, here's a secret length of length. Here's a new signature and a new string here, right? And this is already in hex. If I do echo this into xxd minus r minus p, I get the raw data. And if we put it back into xxd, we can see, so like here's bot1, then it pads it out with a bunch of nulls. In fact, this 80-bit, like all this, there's some stuff right here that needs to do to make the block fill out so that we can add data to it. And that just has to do with how the hashing works. And then here we can see we start adding our data, and we get a new hash. And so in theory, this could work, right? So we can say, get back up here, get rid of you, get rid of you. So the new hash is here. And the new data is, I need to, I guess we can put this here just so we have it. That's wrong. The new data is echo like that into base 64. I better do W0 echo, and then I better do a minus n here because I don't want the new line on the end. And oops, minus W0. And there we go. So now we have this thing. And let's put this here. We still get invalid token, and that is because the secret is not 8 bytes long. The secret is more than that or less than that. We don't know. And that's, so the way to do this is just to try them all. And, you know, I could write up a bash script to do this, but this is where I've been doing a lot of Python development recently, and I'm just going to try to do some like good Python coding to make a kind of neat little script that'll do this for me. So let's go ahead in here and we will create find hash.py. And so do I trust? Yeah, I trust me. Let's say user bin env python 3. So we got that. Let's go ahead and I'm just going to define right up front. The data we have is bot1 bot, so I don't confuse myself in the future. Append is equal to : admin : true. And then the signature is equal to, grab you, where are you? I guess we're in here. In this. This is our known good signature. And so now we have all those kind of just defined as constants at the top. That'll work. I think the easiest way to do this, as I was thinking about how to proceed here, is to go ahead and define a class called hash extender. And I'm going to put right in the top of the class. Where's a good run? Oops, let's see. Go up here. Where do we have a call to hash extender? Right here. Let's just push this right there. So I have that for my, so I can see it as I work. Now the hash extender thing, we're going to need to start it off with a init, like we would do with everything, which will take self. I'm going to pass in the secret length, and that'll be an int. I'm going to pass in the data, the like orig data, which will be a string. In theory, I could probably do this as bytes, but because we know we're going to be working over web, I'm just going to do it as, I'm going to assume all my data is always just non-binary string. Then we need append data, will also be a string. And I guess that's it. Once we have that, we're just going to assume this stuff is kind of constant. We don't have to pass it in. So we can say, and this is going to return, we're going to return, I guess it's going to return nothing because we don't have an init class, right? So cool. And we can do self.secret length, which will also be an int equals secret length. We can do self.signature, which will be a string equals signature self.data. I guess we call it orig data string equals orig data, self dot append data, string equals append data. So I think that's all we need for our init function. Now, what my vision here is, I'm going to create this thing each time I want to run it. So each time I'm going to create this, it's going to go ahead and run hash extender, get the data back, and store it in the result. And that way, then I can just reference. I can say like, hey, generate it with a length of 8, and then I can just get, okay, well, what's the I need to know the hash. I need to know the new data, etc. I need to know the base64 encoded new data. So I'm going to want to, every time I create one of these things, I'm going to want to immediately calculate a bunch of stuff. I'm going to go ahead and create, in general, the best practice is not to put a bunch of calculations in your init function. Your init function is for initializing things. So I'm going to create a new function here called calc. I'm going to call calculate, and we'll say self, and we're going to return none, because we're not going to actually return anything. We're just going to store some stuff, right? So what we need to do is we're going to do a result equals subprocess.run, and we'll see. Can I just import that here? Yeah, again, sweet. So I've got my subprocess.run. Now this is going to be, let's see, opt hash extender, and then I'm gonna have to give it all these arguments. Let's go ahead and grab this right here. We can go like this here. I better put this in its own. It's gonna get. This is the way. I mean, I've always been someone who's like didn't love having tons of white space in here, but like it really is the right way to do it on in Python. So here we're gonna say we'll call this what was this? What I call it? Data, and then this will be append like that. Looks good. Comma. This will be we're gonna our self dot append. Data. Oh, I guess this should be self dot orig data. That. All right, we need to put the signature here. Signature, and we'll do self dot sig. Do I not have a signature in here? I didn't take a signature as a value. Did not one, two. Nope, we're gonna need to add that. So we'll say self signature is another string. Oh, I put it here, I just didn't include it. Okay, so we're passing 4 things in, so we got that. Cool. So we're gonna do self.sig. Not giving me autofills because of this broken stuff here. Okay, we don't need you anymore. Oops. Go straight here to format. We're almost done. Format. 256. Secret. I'm missing a bunch of commas, and this will be self.secret length. Perfect. We're going to need some commas here. Here. Actually make them commas, not okay, I know it's errors. Commas, and I guess we should have a comma here. We should pass that there. Okay, I think that looks good. We are going to run our command now with our data. I want to make sure I do, I think it's capture output equals true, so that we get the output, and then it will come back into result. So let's see, we'll do print result. I'm going to put a breakpoint right here and push, I guess we need to, let's see, what do we call this here? We'll say HE is equal to hash extender, and we need to pass it some stuff. Oh, we can do data, length, our secret length, we're going to just say 8 to begin with. Our original data is data, our append data is append, and our signature is signature, like that. And then we can say he.calculate like that. And if we push F5 to Python debug, Python file, see if this works. Subprocess.run takes expected string, not int. 923. Oh, I bet you self-secret length. Let's make this a string here. Subprocess requires a string, so we rerun that. And we got print results. Let's see. Results. Cool, look at this. Okay, we've got our output here with all of our stuff. And it's looking pretty good. If we play this through the terminal, we can see our result here, a completed process object. So we want to process, parse this down. So I'm going to say, let's see, I'm going to say lines is equal to result dot standard out. That's going to be bytes, so I want to make it into that, and then I want to split on new line. That should give me all the lines. Now, when I do that, can I see this down here? Any better? Let's run to here again, just so I can show you what we're gonna do. So if we say, I wish I should have put a print afterwards so I could actually run this. We'll grab this. I don't know if this is gonna work. Oh yeah, it does. Okay. So the first one is the type. The second one is there. So what I want to do, and I'm gonna put some asserts in here just to make sure I'm making sure my assumptions, like I get a break if it fails. I'm gonna say line 2 starts with new signature. And then I can say self.new signature equals lines 2.split on space. And so where's that? It's going to be 1, 2, 3. Let's just do -1. And that is, so we want the last object there. And then we can do assert lines 3 that starts with, and we'll say new string. And again, I'm just putting those asserts there so that if something comes up funky, I get alerted to it. So I can say self dot new data equals lines 3.split. And we'll do the same thing here, -1. And that's it. Now we're done. We've got our calculate function is going to fill in this new signature and new data for us. And so now we'll have this object that has it. So I can run this and let's go step up. And do I have an H? Can I do he.new data? Yeah, so there I've got he new data and it's looking good. So that's cool. I don't like having to call this twice. Every time I create a thing, I'm going to do it. So what I've been doing in here is I'll come in and I'll just say class method, which means I can run this method off of the hash extender class, not an instance of the class. And I'm going to call this like def generate. And it's going to take a class instead of self. But then after that, it takes the exact same things I have here. Now, is this necessary for my little hacking script? No. But this is like, again, I'm just trying to kind of put some good practices into place. Now, I want the return type to be a hash extender object. I can't use that object here, but if I put it in quotes, the type checker is still smart enough to figure it out, so that works. I can say he equals class, that's the object being called, secret length, orig data, and data, signature. So I create myself an object, I call he.calculate, and then I return he. So now I have this generate method. So now down here, instead of doing all this, I can just say a hash extender dot generate like that, and I don't need that. And let's see, we can do print he, and let's run u again. And let's get rid of the breakpoint. And there's my hash extender object down there. Probably should have put a break here. It's a good time to go ahead. Again, is it necessary? No, but we should make a REPL for our function. So let's see, if we do he, we can see he dot new data. So we've got our data there. Let's make ourselves some string functions, etc. So we can say, oops, I'm probably not, yeah, I want to go here. Def string self returns a string, and all I'm going to do here is do return. And this is like, if I try to print this thing, what's going to happen. So I'm going to make this like all the data I need. So I'll do secret length, self dot secret length, new line, I hash, and I'll do self dot, what was that thing called? I called that the I hash is the new signature. Yep. And then I can say new line, identification, and that'll be self.new data. And I think that's all I need. So now, if I run this again, and I get to this, we printed out the secret length, the I hash, and identification. Now, I don't actually want this hex. I want this to be base 64 encoded. So let's go up here and from B64, from base 64, import B64 encode. So we have that. And now I'm gonna make, again, is it necessary to do it this way? No, but like, it'd be kind of cool too. So I'm gonna do a property, and we'll just call this like def encoded new data self, and it's going to return a string. And so by putting a property here, what that means is I'm going to call this function rather than by saying this thing open parentheses and close parentheses. It's going to be treated just like self.newData, but it's going to call a function to generate it. So I can say return b64 encode self.newData dot encode because it requires bytes, base64 encode it, and then I will decode because I don't want bytes back, and that will look good. And so down here under new encoded new data, just like that. And now if I run this, and I run it, you can see it prints out the stuff here. Perfect. Okay, so all we've done with all that coding is get back to right where we were before just by running it manually. But now, the cool part. I guess, well, we should, if we're going to do it real quick, we'll just take a quick, one more thing. We should really add a repr. Self string like this, and we'll just do return f hash extender seclen self.secret length. Oops, well, and we can do data self.new data, and we can do sig self.new sig. Cool. Okay. That's just like a good practice to be in. It's useful when debugging. I guess I can show you. Run this now. I do HE. You can see that right there. That's what shows up right here. Hash extender, sec length, blah blah blah. So that's just, again, it's useful for debugging. Okay. So the cool part. Now we want to check everything. So we're going to say for I in range 100. It's very unlikely the secret's more than 100 characters. We'll say this, and we will replace this with I. And then we're going to need like if check signature, and we'll pass in HE. We'll do HE dot encoded new data, HE dot new signature. We can break and print HE here. So basically what we're going to do is we need a check signature function that's going to see if it's valid. So we've got our hash extender class. We'll come here and we'll, under there, def check signature. It's going to take in data and a hash. I hash, I'll call it just to match to the thing. It's going to return a Boolean. And what are we going to do? Let's get that curl command we tried earlier. Right here. And just like before, I'll put that here. Perfect. Nice to have my wrap already. Okay, there we go. Word wrap this around. So now we can see what we need to do. We're going to need the request library. So we will import the requests. And then we will say response equals request.get HTTP Ouija.HackTheBox :3000. We're going to use the user's endpoint because that's what we've been using. I think we're going to need to go ahead. Let's space this out like you, there, colon, and this will be headers equals I hash. Oh, I mean that colon, and this will be what did I call it? I hash. Brilliant. And then this will be identification colon, and that will be data. Boom. And so now I can say return not, where's my code here? What's my invalid token? Return not invalid token in response.text. So it's going to say is invalid token in response.text. If not, in reverse. So if it's not in response.text, it will return true. That means our signature is good, which then means we break, which means we can be done. So that quickly now, we can F5 this, and it's going to be running through, hopefully making a bunch of requests, trying a bunch of different types, and we've reached it. And we've got a length of 23. We've got the iHash and identification. We could take this over here and go back to curl. Let's see. So we need, what did I just cut? iHash. We'll come here, put the new hash in, because it does change the hash. It just changes it in a way we can calculate. We'll copy that, paste that in. And database unavailable. That means we completely went through the validation on the identification. We are an admin user now. We just are hitting an endpoint that doesn't do anything. But there's another endpoint that does. That's what I'll continue exploiting. If you're interested in reading about this box, check out the full blog post. I'll have a link in the description. Otherwise, hopefully this was a neat way. The hash extension attack is cool. Figuring out how to wrap it in Python so that we can easily try a lot of them is neat. And yeah, I think that's going to be it for today. Thanks for hanging out with me, and I'll talk to you next time. Bye.